The purpose of this video is to introduce you to an interesting navigational instrument called a Polaris. I did a search online and found very little information about the use of a Polaris, so I thought that an instructional video might be useful. Throughout this video I will use the term bearing, which is a commonly used term, but really I'm referring to azimuths, which range from 0 to 360 degrees, measured clockwise, from 0 or north. Bearings, in the true sense of the word, range from 0 degrees to 90 degrees and are measured clockwise or counterclockwise from north or south. So in this video, when I'm referring to the term bearing, I'm really referring to an azimuth, not a bearing in the true sense of the word. We have here 4 Polaruses, 4 different kinds. They basically do the same thing. We also have a normal compass here. Sometimes a Polaris is called a dumb compass. Dumb because there's no magnetism in the Polaris at all. Unlike a magnetic compass, a Polaris does not point to north, magnetic or true north, unless you set it to point at north. But on its own accord, it has no magnetism in it and it does not point to north, whereas compass does. The compass will reorient itself to north, but a Polaris does not do that. That's why it's known as a dumb compass. Okay, now the simplest form of Polaris, this one is called the Dietz Polaris, and all of them have a compass card that can rotate. They have a set of sight vanes that can rotate, and the compass card can be locked to the body of the Polaris, and the sight vanes can also be locked. So they can move independently, or if both are locked, they can be locked. And obviously when you're taking a sight, you use the sight vane and you line one sight vane up with the other and you get your bearings. That's the Dietz Polaris. This one is called a Dara compass corrector, and it is a Polaris, and any Polaris can be used for compass correction. Again, it's fully gimbaled so that the compass card remains relatively level. It has sighting vanes, a hole in this one, and you sight through that one to the index mark here at your target in the distance. And the sight vanes move independently of the card, and the card can move independently of the frame. And if you notice, there's little index marks on the frame at the cardinal points. So that's the Dara compass corrector. Then we have a more sophisticated Polaris. Same idea though. You have a rotating compass card, a set of sight vanes that can rotate. The Polaris is gimbaled to keep it relatively level. In this case, it's gimbaled in one direction only. And you have a vane clamp, which is the bottom thumb screw. That clamps the vane to the compass card so that they move in unison. And then a top thumb screw is a dial clamp, which locks the compass card to the frame. And just like the other ones, you have a sort of a fiber optic crosshair here on the sighting vane and a slit in the back sighting vane, and you obviously look through the slit, line your target up with the fiber optic crosshair, and then you read your bearing there. Here we have another type of Polaris. This one is gimbaled in two directions. this way and this way so that it stays relatively level. I say relatively level because it hangs up a little bit, and as you can see it's a little bit out of level. Therefore I use a simple Johnson bubble level on there. When you're doing precise work, you want to try to keep it as level as possible. But it's the same idea. The compass card rotates independent of the frame, independent of the box, and it can be clamped so that it does not move independent, so that it's fixed. And also the vane, the sighting vanes can be clamped such that they move with the compass card or independently, like that. Same idea here. You have a crosshair on the far sighting vane. You have an optical slit in the close sighting vane. In this case we have a little reflector here if you're shooting the stars and you take the reflection of the stars through the sighting vanes. That's for night work. And like I say, I generally used a little level on there, like that. This one happens to be made by the Bliss company. B-L-I-S-S. So we have 4 different Polaruses, also called dumb compasses. They are not a magnetic compass. This is a magnetic compass. As you can see, it will reorient to north. In a little bit we'll explain how to use the Polaris to do different functions. In each case, on each of these 4 Polarises, the box or the frame is an integral part of the Polaris. You can see index marks on the frame here. They are parallel to the side of the box. And in use, you set the Polaris side of the box with the index marks parallel to the centerline axis of the ship. Same thing with the Dara. The index marks at the cardinal points, these ones are aligned and are parallel with the square frame of the Polaris. That is set to be parallel with the centerline axis of the ship. The Dietz has a little pointer built in and an index mark on the frame, so the box is set parallel to those two. The side of the box is set parallel to those 2 marks there. Again, this would be placed on the ship parallel to the centerline axis of the ship. In this case, the gimbal frame is set parallel to the one side of the mounting block, and that would be set parallel to the centerline axis of the ship when you're going to use the Polaris. The idea of this video is to demonstrate several uses of the Polaris and how to use the Polaris. So I put together a fictitious fishing trip from Keyport Harbor to West Bank Lighthouse, and we'll be using the New York Harbor NOAA chart number 12327. Before we get started, I'll point out several things on the chart. We're going to be starting out at Keyport Harbor. We're going to sail out the harbor channel to buoy number 1. Then we're going to turn toward West Bank Light, which is here. But after we depart buoy number 1, we're going to head toward a familiar buoy number 1 off Kingsburg. And then we'll go from there to West Bank Light. And looking at the chart, you have Perth Amboy over here to the west, Sandy Hook down here, the Narrows of New York Harbor here with the Verrazano Narrows Bridge, and This is the Earl ammunition pier where they load the ships with ammunition. So again, we're going to start out at Keyport Harbor. We're going to sail out Keyport Channel to number 1 buoy. We're going to turn, go over to the Kingsburg number 1 buoy. From there, we're going to go up to West Bank Light. On May 30th, 2015, we depart Keyport Harbor, New Jersey. Latitude north 40, 26.2 minutes. Longitude west 74 degrees, 12.5 minutes. And we proceed out the Keyport Harbor Channel until we reach the last channel buoy, number 1. We're using NOAA chart number 12327. At that point, we turn east to a course of 091 magnetic and head toward one of our familiar landmarks, the Kingsburg number 1 buoy, about 2.7 nautical miles away. Passing the Kingsburg number 1 buoy, we turn to course 063 magnetic and proceed on a long run toward West Bank Light. So we've come out Keyport Harbor to channel number 1 buoy, which is the last buoy in the Keyport Channel. Then we turn to the Kingsburg number 1 buoy, and now we're on a run toward West Bank Light. About 6 minutes later, we desire to know our position. At this point, we realize we left our handheld GPS back at the dock in our truck. However, we are prepared in that we have our chart, our Polaris, and a table of azimuths of the sun. So we decide to attempt to locate our present position using the 2-bearing method. We ask our helmsman to hold us on a steady course and tell us the compass bearing he is running. He calls out 063 magnetic. We set our Polaris compass card to 063 at the lubber line, lock the card, and bring it to a convenient place on deck that will allow us to align the body of the Polaris with the fore and aft center line of the boat. We scan the horizon for 2 identifiable landmarks that appear on our chart. Ideally, the 2 landmarks will be separated by an angle of roughly 90 degrees. Since the helmsman tells us that we're on a course of 063 magnetic, we have to set that on a Polaris. So this is the lubber line of the Polaris. We rotate it, the compass card, until we get to 063, and we tighten the dial clamp so that the compass card can't move. So we're now sailing from the Kingsburg number 1 buoy toward West Bank Light on a compass course of 063. Now we set up our Polaris along the ship's center line. Since we're headed 063 from here to West Bank Light, we align the Polaris with the center line of the ship. So we've been sailing for 6 minutes from Kingsburg number 1 buoy toward West Bank Light. So we know we're somewhere in between here, but we don't know exactly where. So we'll just take a guess, and we'll set up our Polaris where we think our position is. Now that we have our Polaris on deck and it's aligned with the center line of the ship as we're sailing toward West Bank Light, we look on a chart and we try to identify 2 landmarks that appear on a chart that we can see from our position. One of them is the east tower of the Verrazano Bridge. The other one is the Sandy Hook Lighthouse, and these are roughly 90 degrees apart, so that will work for our 2-bearing fix. Using the sighting vanes on the Polaris, keeping the unit aligned with the ship's center line, we take a bearing on the Verrazano Bridge tower. And we lock the sight vanes, and then we read the bearing, which is 35 degrees, which is a magnetic bearing because we previously set the compass card on the Polaris to our ship's magnetic course. We take a similar bearing on a Sandy Hook lighthouse and get 126 degrees, also magnetic. And we read 126 degrees on our Pelorus. As a check, we take a third bearing on the end of the Earl ammunition pier and get a bearing of 145 degrees. Now we can plot these three bearings. The bearing to our first landmark was 035 magnetic, so we're going to plot that. We come to the compass rose using the inner circle, which is magnetic. We set it up to 35 degrees. Now we're going to transfer that 35 degrees to the east tower of the Verrazano Bridge. And we do that by sliding over like this, and we draw a line. Now we're going to extend that line, and this is our line of bearing to the east tower of the Verrazano Bridge. Now similarly, we're going to plot the bearing of 126 degrees magnetic from the Sandy Hook lighthouse. So we come to the compass rose over here, again using the inner circle, the magnetic. We set it at 126 degrees. We have to move that up to the Sandy Hook lighthouse here by sliding parallel. Now we plot our course, our bearing I should say, there. And we're going to extend that bearing there. So we have plotted our first bearing from the Verrazano Bridge East Tower. We plotted our second bearing from the Sandy Hook Lighthouse, and where the two intersect, that's our two bearing fix, which is right here. Now, as a check, we took a bearing on the end of the ammunition pier, and that is this line here, and it crosses right where the other two bearing lines intersect, which means it's a good check. And this is our two bearing fix position 6 minutes after leaving the Kingsburg #1 buoy toward West Bank Light. So after plotting our two bearing fix, we conclude that our position is north 40 degrees 29.8 minutes, west 74 degrees 06.4 minutes, which is about 2.8 nautical miles off of Kingsburg. And we get the coordinates by projecting our fix point to the sides of the chart, and we read the latitude scale and project down to the bottom of the chart and read the longitude scale. And that gives us our latitude and longitude coordinates. So I'll try to show you a little closer here how what we actually did with the Polaris. Since the Polaris is aligned with the center line of the ship, we set the magnetic bearing of 63 degrees onto the compass card to the lubber line of the Polaris, and we tighten the dial clamp there. Now we're going to take a sight on the east tower of the Verrazano Bridge. So we line up, we look through the slot, line up the crosshair with the Verrazano Bridge in that direction, and then we tighten the vane clamp, and we read 35 degrees. Similarly, we loosen the vane clamp, and we take a sight on the Sandy Hook Lighthouse. We look through the slot, line it up the crosshair, line it up with the lighthouse in the distance. Carefully lock the vane clamp, and we read 126. And then we do our check on the ammunition pier. So we sight through the slot, to the crosshair, to the ammunition pier in the distance. Lock the vane clamp, and we read 145 degrees. After several hours of fishing at West Bank, we decide it's time to return to port, so we head back. We see the sun dropping low in the sky and decide to use the sun to make a check of our compass. The time is 1900 hours 30 minutes local time. We set up the shadow pin on the Polaris, or raise the sight vanes, as the case may be, and align the unit with the ship's center line. We have previously looked up the azimuth of the sun for our particular point in time using one of numerous methods or apps, and find that at 1930 hours on today's date, the sun is at 292 degrees true. So the sun is over in this direction. We take the Polaris and we set the vane to 292 on the compass card. And lock the vane clamp. So now the vane and the compass card move simultaneously. So now, keeping the Polaris compass card as level as possible, we rotate the sight vanes and the compass card in unison until the shadow from the sighting vane crosshair lines up along the center line of the sighting vanes to the reciprocal azimuth of 292, which is 292 degrees minus 180, or 112 degrees. So we're reading 112 degrees here. So the shadow from the sun from this crosshair is lined up with 112 degrees here. So after we've have the shadow of the sun aligned here, and we've rotated the compass card, we read at the index mark that our boat is traveling on a course of 239 degrees true, because this is not a magnetic compass. The true bearing that we're running on, true course we're running on, is 239 degrees. In this case, we know that the declination is 13 degrees west, declination or variation, and we get that from the compass rows on a chart. Therefore, the magnetic azimuth is 252 degrees, which is 239 true that we read plus 13 degrees for magnetic variation. And our compass is reading 252 degrees, so we know that our compass is accurate. The ship's compass is accurate because it compares to the magnetic bearing we got when we used the sun as a reference. So that's a second operation that you can do with the Polaris on a ship. In this case, we've checked our compass, and our compass is accurate for this point of sail. Now, deviation sources on the ship may cause the compass to be inaccurate on other points of sail. So it's probably a good idea during different times of the day to use your Polaris to check your ship's compass on various points of sail. Now, to use the Polaris to check our compass, our ship's compass, using the sun as a reference, we set the bearing of the sun, which we've looked up previously, as 292 on the compass card. And the reciprocal bearing is 112 degrees. Then we rotate the compass card until the sun shadow is lined up through the center of the sighting vane, and the shadow falls on 112 degrees. And at that point, we rotate the compass card to achieve that, and we wind up with 239 degrees true. 239 true. And then to that, we add 13 degrees west declination or variation, and we wind up with 252 degrees, which is the compass course which we're running, and it agrees with our ship's compass. So we know that the ship's compass is accurate on this point of sail. So we started out at West Bank Light, and we're returning to our home port, and we pass Old Orchard Shoal Light. As we continue back toward our home port, having just passed Old Orchard Shoal Light on a course roughly 252 magnetic, we observe a vessel on our port side running approximately northwest in the Raritan Bay East Reach Channel. Remembering the rule of thumb that if a bearing to a crossing vessel does not change, a collision will occur, we decide the prudent action would be to check using the Polaris. So we bring the Polaris up on deck. We set the Polaris aligned with the center line of the ship. We're running on a course of roughly 252 magnetic. And we want to take a relative bearing on the ship that's going up the East Reach Channel. So we set the compass card on the Polaris to 0 at the index mark, and we lock the dial. Now we use the sight vane and we sight the ship that's running in the East Reach Channel. And we read a relative bearing of 322 degrees. We continue running on our course of roughly 252. And after a few minutes of running, we check again the relative bearing to the ship in the East Reach channel. So again, we set the compass card to 0 and lock it in place. We loosen the sighting vanes. We sight through the sighting vanes to the ship in the East Reach channel. Again, we still read a relative bearing of 322 degrees. So since the bearing has not changed, and the rule of thumb is if a bearing doesn't change, a collision is imminent, we think the best thing we could do is to reduce our speed. We maintain our course, but we reduce our speed. So after running a few minutes at a reduced speed, we again check the bearing to the crossing ship. This time, the bearing has changed. It reads now 345 degrees. So what that means is that since we've reduced our speed, that ship will pass in front of us safely. So that's another use for the Polaris, is to take relative bearings on an object to make sure that you're not going to have a collision. Now a close-up of what we do to check that we're not going to have a collision with a crossing vessel. We set 0. Actually, it could set anything, but we set 0 on the compass card with the index mark. The Polaris is aligned with the center line of the ship, and we sight through the sight vane to the ship, which is on our port side. And we read 322 degrees. Then of course we come back later after a few minutes of sailing on our steady course. We do the same thing. We set the dial to the compass card to 0. We sight the crossing ship. Again, the bearing is still 322. So since the bearing has not changed, that means that a collision is imminent. So at this point we reduce speed, and in a few minutes we'll take another bearing. Okay, a few minutes has elapsed. Again, we make sure the compass card is set on 0. We sight the crossing vessel. We read the bearing as 345 degrees. Now the bearing has changed, and we know that the crossing vessel will cross safely in front of us. Now you have seen at least 3 uses for Polaris. I hope this video was useful to you, and hopefully I made the explanations clear enough to get the point across. If you have any further questions, you can contact me at MacGyverL@gmail.com. That's MacGyver with 2 I's, L@gmail.com. Thank you.